I'm going to go to page 377. So adding 30 is about 407. So we used to factor and then cancel. That's the idea for exercises in chapter 6. So whenever you get the fraction, then you simplify it. And I can try the problem number 23 to start with this. So we'll look at a product of two fractions. First one I can write as x minus 2 multiplied by x plus 2 because it has its numerator that I can break into a product of two factors. Denominator is x squared. Second fraction, oh, actually it's x squared times x because it's x cubed for a denominator, right? Second fraction has x squared on the top and x plus 2 in its denominator. So I can cancel x plus 2's and also x squares. So the result will look like x minus 2 over x. So we simplified that fraction and produced the result, and that's all we can do. So point of this section is in factoring and in canceling. So let me try exercise number 31 here. Let's see how we can work that one out. And exercise 31 looks like lots of factorings are going to take place, right? What I can do is start with denominator and write it as x plus 1 times x minus 1, because it's actually x squared minus 1 or minus 1 squared. Then numerator, I can try to factor either with x plus 1 or with x minus 1. So let me try x plus 1, see what happens. If not, I will always change it to x minus 1. Remember, our denominators give us hints how to factor our numerators. So then I'm going to get a 2x for the first place, because I need to multiply 2x by x to produce the first term, which is 2x squared. And then minus 3. So this way, I get myself a start because I factor now the last term, negative 3, as 1 times negative 3. So did I factor it correctly? Well, let's see what happens when I multiply the inside terms and then the terms on the outside. So when I do this, I'm going to get the middle term, negative x, and that's exactly what we have. Oh, this is great. So I can cancel x plus 1 then and move on to the factoring of the second fraction. So the numerator of it, I can factor with x minus 1, because again, that's the only choice the denominator here has, right? So I'm gonna try x minus 1, see that if it works. Usually it does. So then x plus 2 should be the factor of the second factor. So again, let's check this out, see if it works. So minus x, here's the inside product, and the outside product is plus 2x. 2x and minus x is exactly positive x in the middle, so that's great. So I can cancel x minus 1s. Super, so let's see, the last part is left. It's going to be my denominator of second fraction. So I'm going to try 2x minus 3, the first factor that we have here on the top, and looks like, and 2x and minus 3 both should fit in, and indeed, when I multiply 2x by x, I get 2x squared, and then minus 3 times plus 2, right? Is my other piece. So it looks like we do get a factoring. When I double check, the inside product will give us negative 3x, and the product on the outside, 2 times 2 is 4x. So 4x minus 3x is indeed plus x. So it looks like I can cancel everything. How about that? Do you see this? So the answer here is 1, because when everything cancels, it means I divide the same thing by the same thing. Well, the result is 1, and that's what they have here for the answer. So factorings and cancelings. Well, my goal is to give you an idea of these exercises and then move on to the next section that actually talks about finding the sums and the difference of fractions. So, for example, if you look at example number 4, worked out when they subtract 2 fractions with denominators 3 and 2, the goal is to have the same denominator, to turn both denominators into 6. And what people do is they multiply 2 by 2 and 3 by 3. So that's how they get 4, 6 minus 9, 6, which is equal to negative 5 over 6. So when you subtract fractions or when you add fractions, you need the same denominator. So compared to the previous section, this is completely different process. We need the same denominator when we are adding or subtracting. Like in the problem number 17, it's pretty straightforward, because when you add 4 and 2 of 9s, you end up with 6 over 9. So if your denominators are the same, you just add numerators, and this is indeed equal to 2/3, because you can factor numerator 6 with 2 times 3 and denominator 9 with 3 times 3. So you can cancel the 3 and you end up with 2/3. So if your denominators are the same, it's all nice and straightforward. Now, what if denominators are not the same, like in exercise 47? When you try to add a over 2 with 2a over 5. Well, if your denominators are not equal, then you need to make your denominators equal. You need to find the same denominator, and I multiply those denominators together, 5 by 2 and 2 by 5. So my so-called common denominator will be 10. And I must multiply numerators also by the same exact numbers. So the first fraction I multiply by 2, and the second fraction by, first fraction by 5, and the second by 2. That doesn't change my fraction. So I end up with 5a added with 4a. And when I add 5 and 4, I'm going to get 9a divided by 10. So we need to produce the same exact denominator. So then we can add or subtract our fractions. So let me try on the next page, exercise number 53. Exercise number 53 has, again, different denominators. So I'm gonna try to find the same one. So when I do this with first number 4 that doesn't even have denominator, which is added with number 7 over x minus 3, well, I need the same denominator, which is going to be that x minus 3. That's the only choice, I guess, we have. So what we always do is we multiply and divide by that same denominator, which is x minus 3. This doesn't change my number 4 because this could always be canceled, but I don't want to cancel it. I want to add those two pieces together. And that's the idea of my producing the same denominators. So I'm going to have to keep that x minus 3 on the bottom. And then see what happens with my numerator. So I just work with the upper parts. So when I multiply by 4, I get 4x, and 4 times minus 3 is minus 12. And when I add it with 7, looks like these two numbers could be put together. So as a result, I get x minus 3 on the bottom and 4x and minus 5, right, as my top part. So that's it. We added those two fractions. All we cared about is to put those numerators together. So you produce the same denominator and then add your fractions. So some exercise may be rather lengthy, like in the problem number 57 here that says take 3 over x plus 2 plus 5 over x minus 4. So these two denominators are definitely different. So what I need is multiply one by the other. So I'm going to need to multiply by x minus 4, my second denominator, by x plus 2, my actually first denominator, by x minus 4, and second by x plus 2. And this also makes me to multiply upper parts of these fractions by the same exact parentheses. So when I do this, now I'm gonna have to distribute 5 and 3 on the top and see what's gonna come out. So it looks like our bottom parts are gonna be the same. I'll write it down, x plus 3 times x minus 4. And on the top, I'm gonna carefully distribute. So it'll be 3x minus 3 times 4 is 12, plus 5x, and then 5 times 5, which is 25. So it looks like we're going to put those so-called like terms together. So notice I just copied my denominator. I no longer care about it. I add 3x and 5x, so that produces 8x, and then 25 with negative 12 give us positive 13. So these procedures are indeed lengthy and a little bit time consuming. So I guess it'd be a good idea that you try to do the same problems sometime tomorrow, same problems that I'm doing right now. So check as usual the recording of this lecture and you can see what we did and just redo the same exercises. Let me do problem number 66, for example, in the next group of exercises. It says, if you have two fractions with different denominators, now what I'm going to do is factor those denominators, such as x minus 1 times x plus 1 will be factoring of my first denominator minus, and the second fraction will have a denominator also factored with, looks like x plus 1 multiplied by another x plus 1. You see that? If I distribute x plus 1 over x plus 1, I'm going to get x squared and then 2x and then 1. So the question is, what will be my common denominator? Well, it must contain and x minus 1 and x plus 1 and another x plus 1. It must have them all factors of my denominators. So I need here x plus 1 for the first fraction. So I multiply the top by x plus 1, as usual, by the same thing. And for the second fraction, I need x minus 1, right? So I'll have 3 factors in on the first and on the bottom of the second fraction. So let's see what's happening with my result. So I just copied my first numerator, and then I copied second numerator. So I just work with numerators right now because we produced the same denominators, so I don't really care about this any longer. So what I do is I just distribute this carefully. So I don't want to copy this denominator again. I'm just going to distribute this here on the top. So it'll be 2x squared plus 2x. And then negative x, when I distribute, I get minus x squared and plus x. Okay, so let's see what the answer is going to look like. My bottom part is still x minus 1 times x plus 1 multiplied by another x plus 1. Right? And then for denominator, I have 2x minus x squared, which is just x squared. And then 2x and another x will be plus 3x. So we put those fractions together and produce the answer. So looks like exercises here get pretty lengthy, I would say. So I guess that'd be a little bit too much for the quiz. So how about if I give you a little exercise to do just for practice? I'm going to make up a problem and you can try to add this 2 fractions, such as a 1/2 and 1/3. So that'd be our little quiz for today. So please add 2 fractions and produce common denominator, which is going to be probably 2 times 3, right? Which is 6. So that's the hint. So once you get the answer, the fraction, well, just put it in the chat. That'd be our little quiz for today.